ಕ್ವೆಶ್ಚನ್ ಮಾಡಿದ್ರಿ ನೀವು ಹಂಗ್ ಮೆಸೇಜ್ ಕಳಿಸ್ರಿ ಅದಕ್ಕೆ ಹೇಳಿದ್ರಿ ಕಳಿಸ್ರಿ
ಕಳಿಸೇ ಬೇಡ ಅಂತ ಮೆಸೇಜ್ ಮಾಡೋಣ
ಯಾಕ್ರಿ ಸರ್
1.29 AM
ನಾನು 11:30 ಸರ್ ಟೈಮಿಂಗ್
ಬಟ್ ನೀವು ಮಾಡಿಲ್ಲ in the early morning it's better best better to start the questions on chemical bonding. It may help for your examinations also. Good idea. Right. Good afternoon, dear students. Welcome back to the chemistry class. Yes, it is live. In the previous class, we have completed the Poisson's rule, polarization, polarizability, and polarizing power of cations, anions, total method procedure. Okay, in today's sessions, we are going to discuss about the molecular geometry, shapes of molecules, shape of molecules, geometry of molecules. So, how we are going to predict? VSEPR theory, valence shell electron pair repulsion. Next concept, the important one. Valence shell electron pair electron pair repulsion. VSEPR theory. So first, let us understand what are the postulates of this theory, and then we'll move for its applications. First, its postulates, and then its applications. So what is meant by this VSEPR theory? Valence shell electron pair repulsion, and how it helps in predicting the geometry of molecules. Okay. So valence shell electron pair repulsion theory, the main basic assumptions are it gives an idea of a geometry of molecules. So here the shape of a molecules can be predicted based upon the total number of electron pair present in it. You can take any one molecule. Suppose if a molecule is a diatomic, what will be its structure, geometry, how it arranged? Only two diatomic species. AB is a diatomic species. What is its structure, possible structure, geometry? AB can be represented by some bond. It is A and this one is B. 180. So linear 180. Linear structure. If in a diatomic molecule, suppose if we are considering the polyatomic molecule, A, B, C, D, something. In a polyatomic molecule, if it is diatomic, either A or B is a central atom, central ion or atom, and other one is attached to it. Whereas in case of polyatomic molecule, if polyatomic molecule is considered, in that one atom will be present at the center, that is we can call central ion, central atom, central metal atom, and remaining are attached to it in 3 dimensions. So what is its arrangement? If suppose we are considering triatomic molecules, AB2 or ABC or ABL. A is an atom, central atom. B is bond pairs. L represents lone pairs. So total around A to B atoms are there. So this is, it may be its arrangement. A, B, and another one is B. The arrangement, how we are going to write? Possible structures we can write. But what is the actual structure? What is the actual geometry of that molecule? That can be predicted according to VSEPR theory. The main basic postulates of this theory is, if a molecule is diatomic, it always have a linear structure. In the case of polyatomic molecule, the one atom is treated as a central atom, and remaining are attached to it. Now, in the central metal atom, you need to check the total number of electron pairs. So, what is meant by electron pairs? Is total number of bonds and lone pair of electrons. So, for example, if water is considered, just water, H2O, H2O, you are going to write a structure like this, with oxygen containing two lone pair of electrons. So, in this, the central atom is hydrogen or oxygen? Oxygen is central metal atom. Central atom, it is not a metal, central atom. How many bonds? Two bonds. How many lone pairs? Two lone pairs. So around the central atom, two bond pair plus two lone pair. Total how many electron pairs? Four electron pairs are there. So around this central atom, two bond pairs and two lone pair of electrons. Total four electron pairs are present. So total number of electron pair decides the geometry of molecule, shape of molecule, that can be predicted based upon the total number of electron pair. VSEP number, valence shell electron pair number. So if it may be 2 electron pairs, 2 to 7, 2, 3, 4, 5, 6, 7 electron pair. So you need to calculate the total number of electron pair, and in that electron pair, how many lone pair and how many bond pair. For example, if I am considering the ammonia, NH3, how many bond pairs? 3 bond pair, because nitrogen is surrounded by 3 hydrogens, so 3 bonds with 1 lone pair. So it is 3 plus 1, again 4 electron pair. Even though they are having the same number of electron pair, but its structure or geometry is different. Bond angles are different, properties are different. So in order to predict its geometry, how many lone pair and how many bond pair, or total number of electron pair, you need to calculate first. If you calculate, then you can predict its geometry, hybridization, and its stability. What is the possible bond angles, repulsions, which type of repulsions are strong and weak, you can predict. Okay, now the structure of a molecule can be predicted based upon the total number of electron pairs. So note down some postulates, basic assumptions of VSEPR theory. The first one, the total number of valence shell electron pair, basic postulates of VSEPR theory. The total number of valence shell electron pair decides the shape of molecule. Total number of valence shell electron pair decides the shape of molecule. Decides the shape of molecule. First. The second point, if a molecule containing only 2 atoms, then its structure is, a bond angle is 180. Structure is, that is, we can call it linear. Yes. If a molecule containing diatom, 2 atoms, if a molecule containing only 2 atoms, then it is always a linear. The shape of molecule containing only 2 atoms, is always linear. If it is linear, then of course bond angle baruttadalla. First of all, only two atoms are there. How we are going to predict the bond angle? I think bond length, bond angle, bond parameters definition. I will bond parameters. So bond parameters. Okay. First note on this. I will discuss those bond parameters. Bond length, bond strength, bond angle, and bond order. I think it is left. Bond angle. Angle between two orbitals which containing bonding pair. For example, if it is a central atom, two hydrogens are there. Two hydrogens. So these are the orbital which containing bond pair. The orbital which containing bond pair electron, and these are lone pairs. The angle between two bond pairs. The angle between the orbital containing bonding electrons, or angle between two bonds, are called as is known as bond angle. This is the bond angle. That means the angle between two orbitals which containing bonding electrons. So these are the non-bonding, these are the bonding electrons. So this angle is known as bond angle. So if it is a only diatomic species, 1, 2, A and B, how we are going to find the bond angle? In this case, the bond angle we cannot predict. It is a linear structure. It is always linear. Next. The shape of molecule containing polyatom can be predicted by knowing total number of electron pairs. The shape of molecule contains the shape of molecule or geometry of molecule containing polyatoms. The shape of molecules containing polyatoms in which one is central atom, and other atoms are attached to it. Polyatoms in which one is a central atom and other atoms are attached to it. The shape of molecule containing polyatom can be predicted by knowing total number of electron pairs. That is bond pair plus lone pair. Next, as you know that electrons in an atom or a molecule which is present around the nucleus, right? For example, this is the nucleus and this is the orbit in which electrons are present. Now in this case, if suppose assume that 4 electrons are there, valence electrons are 4 or 5 valence electron, where it is present 1 electrons, suppose 3 electrons are there, boron, aluminium, gallium, that family element, 3 valence electrons. So 1, 2, 3, is it right? How they arrange? Far away from each other, apart from each other. Why? Because of repulsions. So electrons around the nucleus that tends to repulse with each other, right? Tends to repel. So they try to occupy a maximum distance between them where the repulsion is minimum. So in this case the repulsion is maximum, therefore the electron tends to move apart from each other. So therefore they repulse due to this electronic repulsions. So total 3 volts. So these electrons which occupy as place or space in such a way that they keep a maximum distance between them where the repulsion is minimum. If repulsion is minimum, that state is maximum stable state, right? the electron in an atom or molecule tends to occupy a maximum distance between them where the repulsion is minimum. So this is another postulate, because in a molecule the electron bond pair as well as lone pair which are surrounding to the atom nucleus. In case of oxygen, so two lone pairs and two bond pairs are surrounding. This is one orbital, second orbital, third and fourth orbital. Two orbital containing bonding electron, two orbital containing non-bonded electrons. So these are bond pairs and these are lone pairs. So usually these electrons do not present at nearer to each other. They tend to repulse with each other, because it is tendency, electrons repulse with each other, right? So therefore the next postulate is electrons in an atom or molecules tends to repel with each other. Electrons in a molecule tends to repulse with each other or tends to occupy a position. Electrons in a molecule tends to occupy a position in which it exerts minimum repulsion. It exerts minimum repulsion. Maximum distance between them. Maximum distance between them. The electrons in a molecule tends to occupy positions in which it exerts a minimum repulsions or maximum distance between them. They tends to occupy positions where the repulsion is minimum, that is where it is maximum stable. And in this case, electrons tends to repulse with each other. Now we have two types of electron pairs. One is bond pairs and other one is lone pairs. So here in this case, can you identify how many types of repulsions are present? What are those types? So it is lone pair. Lone pair may repulse with each other. Or else lone pair and bond pair repulsion, and other one is bond pair and bond pair. So three types of repulsive interactions are there which is present. One is in between. The order of electronic repulsions follow. First one is lone pair, bond pair, and other one is bond pair repulsions. So in which case the repulsion is more? Can you predict in which case the repulsion is more? Yes, lone pair repulsion is more, because bond pair means those electrons are involved in the bonding, they are not free. So repulsion is more, lone pair repulsion is more because they are free. But here one is free but other one is busy in bonding with other molecule, bond pair. So therefore this repulsion is less. If both are busy in bonding, bond pair repulsion is further less. So lone pair repulsion is greater than lone pair bond pair, which is more than bond pair repulsion. Lone pair bond pair, and bond pair. The order of repulsion. Right. Now, its applications, how we are going to predict the geometry. Or fast. Now, we just write one table and then we illustrate the example. VSCPR. So, in order to predict, yes, the electrons are polarizing, right? First, which electrons is highly polarized? A sound first three there. So more polarized ion, high tendency to undergo distortion towards the other. Cousin's rule. In a class I grow. Okay. Strongly polarizing.
Strong.
That means there is a high power to get polarized. Polarizing power of that ion is more than this nucleus. ಈ ಕಡೆ ನೋಡ್ತಾ ಇಲ್ಲ ಆ ಕಡೆ ನೋಡ್ತಾ ಇದ್ದಾರೆ ಅಂದ್ರೆ polarizing power ಅದರ ಜಾಸ್ತಿ ಇದೆ. Only for that ion, right? In order to find the shape of molecules, we need to calculate lone pair bond pairs, right? So total number of lone pairs is to the total number of bond pair. So if you calculate lone pair bond pair, sum is equal to electron pair. So in order to find this table is very important. Idu one gottidare nimu 3 class 4 to 5 classes ella concept cover agutte. Questions are mainly based upon this table. Which of the following is isostructural? Identifying the which type of hybridization is present. In which case the bond angles are same. In which case the repulsive interactions are more. Number of questions on this table. First, you need to calculate total number of lone pairs and bond pairs. Bond pair, lone pair, electron pair. Electron pair is nothing but lone pair plus bond pair. So this electron pair is nothing but bond pair plus lone pair of electron is, that is electron pair. If the total number of electron pair is equals to 2, total number lone pair plus bond pair is equals to 2, then the structure or geometry or the shape is linear. Before that, I will hybridization and shape. Hybridization, the concept we discuss tomorrow. Actually, this concept is we are going to discuss in separate heading under the heading of hybridization, SP, Sp2, Sp3, etc. ಇಲ್ಲಿ ಹಾಕೊಂಡ್ಬಿಟ್ರೆ ಎರಡಕ್ಕೂ ಕವರ್ ಆಗ್ಬಿಡುತ್ತೆ. Hybridization and structure or geometry. 2, it is Sp, one s orbital and one p orbital. Sp hybridization shape, it is linear. If the total number of electron pair is equals to 3, then Sp2 hybridization structure is trigonal planar. If the lone pair electron pair is equal to 3, if the electron pair is equals to 4, two possibilities are there. It is Sp3 hybridization. In inorganic part, dsp2 is also possible. dsp2, but we are not going to discuss this hybridization in this concept. So sp3 hybridization, its structure is tetrahedral arrangement. If dsp2, it is square planar sp square planar, but we are not going to discuss this right now. Next, if the electron pair is equals to 5, sp3d hybridization, then the structure is 5 means pentagonal, and the more stable structure is trigonal bipyramidal. TBP, trigonal bipyramidal shape. This is unstable. TBP is more stable structure for 5 electron pairs. If 6 electron pairs are there around the central atom, if total number of electron pairs is equal to 6, then the hybridization is sp3d2 Sp3 D2 octahedral structure. Octahedral structure. Octahedral structure is nothing but square bipyramidal structure. Actually, it is square bipyramidal. Just to remember this octahedral, no need to write this. Else, if you want, you can note down square bipyramid. Square bipyramidal structure. If the total number of electron pair around the central atom is 7, then it is Sp3 hybridization, and it is a distorted octahedral. Distorted octahedral. Distorted octahedral. Or you can write PBP is more stable. What is meant by PBP? It is trigonal bipyramidal, and this one is pentagonal bipyramidal. This is pentagonal bipyramid. Bipyramidal structure. It is very basic level. Now, this is just I have written the electron pair. Now, in each case, again some different electron pair, lone pair bond pairs are there. If total number of electron pairs is equal to 2, that is possible. In this case, 2 bond pair and 0 lone pair, then it is 2. 1 plus 1 is equal to 2, but that is not possible. If 1 lone pair and 1 bond pair, there is no bonding. For example, A is the central atom, 1 bond pair B and 1 lone pair. 1 lone pair and 1 bond pair. So usually this type do not exist. So next, second one, 3 electron pairs. How you are going to write the 3 electron pairs around the central atom? 3 electron pair. That means here it is 3 0 or else 2 1. 2 1 is possible. 2 1. Once again, I am going to discuss this type. This is AB2 type of AB2. AB2 type. If electron pair is 2, this is the central atom. 2 bond pairs. 2 bond pairs. This is A central atom, A B3 or else A B2L. A B2L. In difference actually. AB3 means A is the central atom, 3 bond pairs are there. Here in place of 3 bond pairs, 2 bond pair with 1 lone pair. Right? A B3L type. Which type it is? A B3L type. One more bond pair, you just replace one lone pair. A B L2. Is it possible? Possibility is first morphometer, other than the secondary. A B L2 is also possible. If the electron pair is equals to 2, if the electron pair is equals to 2, possibilities, it is A B2 type. Other possibility, A B L type. A B L. Study model. Second, if the electron pair is equals to 3, then A B3, A B2L. If the electron pair is equal to 4, what are the possibilities? A B4, A B3L, A B2L2. 3 categories ಬಂದಿರುತ್ತವೆ. Examples ನೀವೇ ಹೇಳ್ತೀರಿ. Just I will give the examples. You need to identify everything. If the electron pair is equals to 5, AB5, just replace one bond pair by lone pairs. A B4L, A B3L2, A B2L3. A B2L3. If electron pair is equals to 5. Next, if electron pair is equals to, if the electron pair is equals to, if the electron pair is equal to 6, if electron pair is equal to 6, AB6. Next type AB5L, AB4, L2, AB3, L3, AB2, L4. If electron pair is equals to 7, AB7, AB6, L, ಒಂದು B ಕಮ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಒಂದು L ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, AB5 L2, AB4 L3, AB3 and L4, AB2 L5. Possibilities are there or not? We'll check it first. So possibilities were there. In this L5, so these do not exist. Now plus up to 2 to the 4 plus 5. Else even it may be possible. We'll check it first. Structure with examples. We'll study first. So what are the electron pairs? If electron pair is equal to 6, then how many lone pair and bond pair you need to find out, right? Yes or no? Yes. So look at this. If the electron pair is equal to 2, what is the hybridization? Hybridization? Sp3 hybridization. Its shape is linear. What will be the bond angle? Pakka, confirm? Yes, 180, because the central atom is the 2 bonds. So that means it's a structure. So shall I remove this one?
Yes.
Look at the structures. If electron pair is equal to 2, central atom is A, which is surrounded by 2 bond pairs. 2 bond pairs. Structure is linear. The bond angle is 180. If the electron pair is equal to electron pair is equal to 3, this is 2. Next one, A, 3 bond pairs are there. 3 bond pairs. 3 bond pair means 1, 2, 3. This is the possible structure of 120, 120. Trigonal planar. Bond angle is 120. Here also you can mention 180, 120. If it is tetrahedral, if 4, look at this. In this case, we'll take one example. First, this type, AB2 type example. Carbon dioxide. Good. Carbon dioxide is an example of AB2 because only 2 bond pair, no lone pair. Look at the group of elements in the periodic table. First group containing how many valence electron? 1. So it can form only 1 bond, right? Second group, 2 electrons are there. So second group, beryllium, magnesium chloride, calcium chloride, beryllium chloride. So if such examples are given, what is the hybridization involved in BeCl2? What is its shape? Identify the bond angle. So first, one example illustrate ಮಾಡ್ತಿದೆ ನೋಡ್ರಿ. The central atom is beryllium. In beryllium, how many valence electrons? 2 valence electrons. Confirm? So in beryllium, 2 valence electrons are there. So 2 valence electrons which shares with 2 chloride ions. So one bond is formed. So 2 bonds. Here electrons ittu. In beryllium, 2 electrons were there. 1 electron is shared with chloride. 1 bond is formed. So 1 bond pair. Another electron is shared with another chloride ion. So 2 bond pair. Over. Is any electron is remaining? So no lone pair of electrons. Only 2 bond pair. So in this case, it is AB2 type. No lone pair of electrons. AB2. Okay, good. Carbon dioxide. You are saying carbon dioxide. Let's see. Carbon. How many electrons? 4 electrons. How many bonds? 1 oxygen can take how many electrons? 2 because it is a divalent. So it is 1 bond pair. Even though 2 electrons are shared, it is considered as 1 bond pair. And another oxygen, another bond pair. So 2 bond pair. Is any electron is remaining? No. So electrons are not remaining. So therefore, this is also containing 2 bond pair, 0 lone pair. Total electron pair is equal to 2. The structure is linear. Bond angle is 180. Good. SO2. If I am considering SO2, again same. No, it is different. Sulfur, how many valence electron? 6 valence electrons are there. In this 6 valence electron, how many bond pairs? One oxygen takes 2 electrons and it make one bond pair. Second oxygen take 2 electrons and it also make another bond pair, 2 bond pair. Remaining 2 electrons, that means 1 pair, 1 lone pair, 2 bond pair. So in SO2, it is containing 2 bond pair, 1 lone pair, total 3 electron pairs. 3 electron pairs. Can you identify the lone pair bond pairs? Can you identify the lone pair and bond pair present in a molecule? Yes. How many lone pair and bond pair in NH3? Good. 3 bond pair, because number of bond is nothing but it is bond pair. 2 oxygen, 2 bond pair. 2 oxygen, 2 bond pair. 2 chloride, 2 bond pair. 3 hydrogen, 3 bond pair. Lone pair has 2. 1 confirm? Confirm? Yes, 1 lone pair. Good. Reason? Total 5 electrons are there. 3 hydrogen takes 3 electrons, it forms 3 bond, and 2 electrons are remaining, 1 bond. Aluminum chloride, AlCl3 has identified. AlCl3, it is contained 1. 3 bond pair, lone pair 0, because valence electrons are only 3. 3 chloride, 3 bond pair. So total electron pair is equal to 3 plus 0, 3. You can identify. In water, H2O, 2 bond pair, 1 lone pair. Good. Check H2O. No. 2 lone pair. Confirm? Because 6 electrons, 1 hydrogen, second hydrogen, 2 bond pair. Remaining are 4. 4 is nothing but 2 lone pairs. 2 lone pair, 2 bond pair. Total 4. Confirm? Yes. In PCl5, 5 bond pair, 0 lone pair. 5 and 0. Xenon oxidichloride. Central atom is xenon. Central atom is xenon. One, 2, 3, 4, 5, 6, 7, 8. Total?
3 bond pair.
Yes. 3 bond pair. Confirm? Only 2 lone pair? 2 fluoride. Fluoride is monovalent. It requires only 1 electron. So 1 fluoride, second fluoride. 2 bond pair. Oxygen is divalent. It takes 2 oxygen. It is oxygen. Oxygen 1, 2, 3. 3 bond pair over. Remaining electrons 4. 4 is nothing but 2 lone pairs. So total 5. Mr. Confusions. First, central atom. In central atom, how many valence electrons are there? Number of valence electrons. Among those electrons, how many electrons are shared? In NO2 minus, confusion bada, NO2 minus. Central atom yaudu? Valence electron is 2. So minus again indicate madtare. 1 electron is gained. So total is 1 electrons. So
2 bond pair, 1 bond pair.
yes, good. 2 bond pair, 1 bond pair. Because nitrogen 5 valence electron, minus 1 means 1 electron is gained. So total 6. And out of these 6, oxygen is divalent. 2 oxygen is 4 electrons is involved in the bonding. 2 bond pair, 1 is lone pair. So total number of electron pair 1. Is it clear? Right. Okay. NH4 plus. NH4 plus.
4 bond pair, 0 lone pair.
4 bond pair, 0 lone pair. Correct? Yes, good.
Sir, 3 bond pair,
1 lone pair. 1 ಪಾಸ್ ಆಗ್ಬಿಟ್ರಲ್ಲ ಇದಕ್ಕೆ ಹೌದಲ್ಲ ನಂಗೆ ಗೊತ್ತಿಲ್ಲ ನೋಡು 1 2 3 4 5 ICL5 ಅದು ನಾನು ಹೇಳಿದೆ
Sir, five bond pairs.
Bond pair because iodine is halogen. Halogen means 7 electrons. 7 line ಹೋಗ್ಬಿಟ್ಟು ಉಳಿದಿರತಕ್ಕಂತ 2 one lone pair 5 bond pair total 6 hybridization structure okay bond angle ಬಗ್ಗೆ ತಿಳ್ಕೊಳ್ಳೋಣ what is the bond angle how we are going to predict the bond angle circle ಏನು almost this is the central atom if only two bond pair just divide the bond angle is so 360 by 2 360 by 2 180 360 by 3 if 3 electron pair 120 see that if any lone pairs are present then the bond angle varies if all are bond pair symmetric structure so bond angle is exactly equals to 120 if two bond pair one lone pair then something repulsions will increase so as a result the bond angle decreased ಅರ್ಥ ಆಗಿಲ್ಲ ಆಯ್ತು 4
but how will it come from that angle?
which one
The case towards the
yes the case 3 in this case the bond angles varies I said no the bond angle is varies examples we'll consider one example aluminum chloride or boron trifluoride is one example boron trifluoride 4 next CH2 is a compound CH2 side CH2 carbon next element carbon silicon germanium etc if we are considering that element instead of carbon if we take carbon silicon dichloride SiC so these are the two compounds I have given whether they having same structure or different in this case boron central atom valence electron in this case the bond pair is equals to 3 idu nanu heltene lone pair ಎಷ್ಟು ಹೇಳ್ತೀನಿ ಬೇಡ bond pair is equal to 3 lone pair 1 0 1 0 1 0 because boron valence electrons are 3 those 3 are already shared so 0 total electron pair 3 so only bond pairs are there trigonal planar so therefore bond angle is 120 360 by 3 it is 120 degree next let's come to this example silicon dichloride two bond pair one lone pair because 4 electrons in that 4 electrons 2 are involved in bonding 2 bond pair remaining are 2 so in this case bond pair is equals to 2 lone pair is equals to 1 total is again 3 but in this case boron trichloride and central atom 2 chloride ions are there with 1 lone pair bond pair bond pair bond pair bond pair bond pair bond pair repulsions are same ಎಲ್ಲರೂ ಬಿಸಿ ಇದ್ದಾರೆ ಯಾರು ಮಾತಾಡ್ತಾ ಇಲ್ಲ 3 ಜನ ಇದ್ದಾರೆ 3 ಜನ ಓದ್ಬೋದು ಕೂತಾರೆ ನೋ ಡಿಸ್ಟರ್ಬೆನ್ಸ್ ಇಂಟರಾಕ್ಷನ್ಸ್ ಆದ್ರೆ ಏನೋ ಸ್ವಲ್ಪ ಡೌಟ್ ಕೇಳ್ತಾರೆ ಅಷ್ಟೇ ಮಾತಾಡ್ತಾ ಇದ್ದಾರೆ ನೋ ನಥಿಂಗ್ so it is trigonal planar okay good but in this case it is lone pair now consider ಮಾಡಬೇಕು ಇಷ್ಟೇ v shape it is v shape or we can call bent structure so in this case this is lone pair ಇದು ಓದಂತ ಅವಶ್ಯಕತೆ ಇಲ್ಲ ಇಬ್ಬರು ಓದ್ಕೊಂಡು ಕೂತಿದ್ದಾರೆ ಒಬ್ಬರು ಮಾತಾಡ್ತಾರೆ ಏನು ಓದುತ್ತಿದ್ದು ಇದು ಮತ್ತೊಂದ್ಸಲ ಡಿಸ್ಟರ್ಬ್ ಮಾಡ್ತಾರೆ ಸುಮ್ಮನೆ ಪದೇ ಪದೇ ಡಿಸ್ಟರ್ಬ್ ಮಾಡ್ತಕ್ಕಂಥ ಮನುಷ್ಯ ಮನುಷ್ಯ ಸ್ವಲ್ಪ ದೂರ ಕೂಡ ಒಂದು ಸಲ ಬೇರೆ ಕಡೆ ಕೊಡ್ಬೇಕಾಗುತ್ತೆ ಸ್ವಲ್ಪ so if lone pair of electron is there then lone pair bond pair repulsion is more ಸೊ ಇನಿಷಿಯಲಿ ಇದು ಇರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಯಾವ ತರ ಇತ್ತು ಮುಂಚೆ ಸ್ವಲ್ಪ ಈ ತರ ಇತ್ತು. ಈಗ ಒಂದು ಲೋನ್ ಪೇರ್ ಬಂದ್ರೆ ಏನಾಗುತ್ತೆ ಅದಕ್ಕೆ ಬಿಟ್ಟು ಸ್ವಲ್ಪ ದೂರ ಆಗ್ಬಿಡುತ್ತೆ ಕಡೆ ಬೇಡ ಕಡೆ ಅಂತ ಕೆಳಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ ಆಸ್ ಎ ರಿಸಲ್ಟ್ ಬಾಂಡ್ ಆಂಗಲ್ because of lone pair bond pair repulsion increases, so this bond angle decreases. It is less than 120, not equals to 120. You can predict less than 120 in this case. Tetrahedral square planar is 90 because by 4 360 by 4 mathematics 360 by 4 90. But in tetrahedral structure carbon methane class methane by 10th element CH4 methane tetrahedral structure 109.28. In tetrahedral structure 109 109.28. In square planar it is 90. Square planar exactly the plane. Next, if it is 5 pentagonal square planar central atom 4 bond pair tetrahedral structure, correct? This is the tetrahedral structure 109 bond. If pentagonal metal 1 2 3 4 5 pentagonal 360 by 5 72, so bond angle is 72 in pentagonal. If this can be written as trigonal bipyramidal metal 1 2 3 it is triangle, one is above the plane and one is below the plane. One is triangular plane, one is above the plane and other one is below the plane. Adon rethi pyramid form agutte. So from this point it is a pyramid. Mane kya koodsidanga one pyramid above and other one is below. Bipyramid, trigonal bipyramidal. It is pentagonal trigonal bipyramidal structure. Next 6 octahedral. So in this case if it is trigonal pentagonal different angles.
Here in bipyramid we will be getting solid angles.
Solid angles, why?
Because
3 dimension. It is also 3 dimension pentagonal. See, in this case it is 72 degree. In this case, two types of bond angle we are going to observe. One is 120 because triangle it is 120, and one is exactly present on the plane. Then bond angle 90, and other one is 90. So 90 and 120. Two types of bond angles are there in trigonal bipyramidal. If electron phase is equal to 6, octahedral structure. Octahedral has many three. Octahedral structure. Simple structure. 2 times ಬರೀತೀನಿ. ಇದು ಎಲ್ಲರೂ ನೋಡಿದ್ರೆ? ಡೈಲಿ ಪೂಜೆ ಮಾಡ್ತೇವೆ. Central atom actually ಯಾವ ತರ ಬರೀತೀವಿ ಅಂದ್ರೆ metal. So first square planar central atom 4 bonds 1 2 3 4. One is above the plane and other one is below the plane. ಅರ್ಥ ಆಗಿಲ್ರಿ? Square plane 1 2 3 4. One bond is present above the plane. ಇಲ್ಲಿನ ಮೇಲೆ ಬಂದ್ಬಿಡುತ್ತೆ. 90 degree in square plane 90. So octahedral, if in this case square 90 and this is also 90 because it is present above the plane. So how it form pyramid? Yes, so from this point to one pyramid, square bipyramid. It is one square, one is above the plane and other one is below the plane. One is a square bipyramidal, or you can call octahedral structure. So this is one square. From this central atom, this is the central atom and this is the points. What confusion is that? Octahedral structure. Central atom 4 bonds 1 2 3 4. 4 bonds. One is present above the bond, above the plane, and other one is below the plane. Now, from this point, it is present on the square plane. So, from this point, we can connect all 4 corners. This is pyramid, above the pyramid, and similarly below the pyramid. Square pyramidal structure. So if electron pair is equal to 7, one more bond is present in this, so therefore this octahedral structure is distorted octahedral. So E part alli mainly you need to calculate number of bond pair, number of lone pair. If you are able to calculate those two, then it is enough. You can find out or you can solve the problems on this. And in previous year competitive examination, maximum questions are asked based upon this. Which of the following is isostructural species? This question just repeat agitha, and you can solve some of them objective problems on this. Correct. In the next class, we will discuss